Good morning friends. Today we are going to see the next point from the topic oscillation, that is the composition of two S.H.M having same period and along the same path. Friend, here we are going to derive the equation by the analytical method. For our convenience, the equation is linear, so I have divided the equation into three parts. In first part, we are going to find out the composition. In second part, we are going to find out the resultant amplitude, and in the third part, we are going to find out the phasor angle. So the equation will be divided into three parts. So first, we will see the part one, that the composition of two S.H.M. S.H.M stands for the simple harmonic motion. Let us consider x1 is equal to a1 sin omega t plus phi 1 and x2 is equal to a2 sin omega t plus phi 2. These are the two waves which are traveling along the same path. When they will meet each other, then its resultant displacement will be x is equal to x1 plus x2. X is equal to a1 sin omega t plus phi 1 plus a2 sin omega t plus phi 2. So this is the addition of these two waves. Now we have to use the formula of sin c plus sin d. So here we can apply the formula of sin c plus d, or you can say about the sin alpha plus beta. Sin alpha cos beta plus cos alpha sin beta. In that way we can write. So I can write the a1 into bracket sin alpha cos beta means sin omega t cos phi 1 plus cos omega t sin phi 1. So this is for the first bracket. So a1 sin omega t plus phi 1 sin alpha cos beta plus cos alpha sin beta. So sin omega t cos phi 1 plus cos omega t sin phi 1. So we will apply for the second bracket plus a2 into the bracket sin omega t cos phi 2 plus cos omega t sin phi 2. So here also we have applied the same formula. Friends, if we are writing one below the other, then it will be very easier for us to take the common terms. You can observe that the sin omega t will be the common here. So we can write this part as x is equals to, take sin omega t as a common into the bracket. When we are taking the sin omega t as a common, then in the bracket a1 cos phi 1 plus a2 cos phi 2. You can observe that the sin omega t is a common. a1 cos phi 1 plus a2 cos phi 2. Now take cos omega t as a common. So plus cos omega t. So into the bracket a1 sin phi 1 plus a2 sin phi 2. So this is a part here. Now friends, here we have to consider r cos delta is equals to a1 cos phi 1 plus a2 cos phi 2, and r sin delta is equals to a1 sin phi 1 plus a2 sin phi 2. Substitute this value, so we can get x is equals to sin omega t r cos delta plus cos omega t r sin delta. Take r as a common. Sin omega t cos of delta plus cos omega t sin delta. So here sin alpha cos beta plus cos alpha sin beta. So x is equals to r sin omega t plus delta. So this is the composition of two S.H.M. So this is the first part. Again I am going to explain this first part once again. So remember this equation is a linear and it is divided into three parts. So I have explained the first part here. So composition of two S.H.M. Let us consider the two waves are traveling in the given medium. The displacement of the first wave is x1 is equal to a1 sin omega t plus phi 1, x2 is equal to a2 sin omega t plus phi 2. Now the composition of two waves will be x is equal to x1 plus x2. So x is equal to a1 sin omega t plus phi 1 plus a2 sin omega t plus phi 2. Then apply the formula of sin c plus sin d, or you can apply the formula of sin alpha plus beta. So sin alpha plus beta, sin alpha cos beta plus cos alpha sin beta plus a2 again sin omega t cos phi 2 plus cos omega t sin phi 2. Remember, as we have written the step one below each other, then it means very convenient for us to take out the common term. So sin omega t is a common, so remaining part is a1 cos phi 1 plus a2 cos phi 2. Take cos omega t as a common, so a1 sin phi 1 plus a2 sin phi 2. Then we have to consider the bracket term as r cos delta is equal to a1 cos phi 1 plus a2 cos phi 2. R sin delta is equal to a1 sin phi 1 plus a2 sin phi 2. Then the step will become x is equal to r sin omega t r cos delta plus cos omega t plus r sin delta. Take r as a common, so sin omega t cos delta plus cos omega t sin delta. This is the formula for the sin omega t plus theta, means sin c plus d, sin alpha cos beta plus cos alpha sin beta. So sin alpha plus beta formula is there. Remember, this is the total mathematical part here. So this is the equation for the composition of two S.H.M. Friends, the second part which we are going to see is that of the resultant amplitude, and that is related with the first part. Okay, so I hope you have understood the part first. Now we are going to see the part 2. Part 2 is the equation for resultant amplitude. Equation for resultant amplitude. So here this equation will depend on this part which we have derived here, r sin delta and r cos delta. Okay, so I am writing here, I can consider this as equation number 1 and this as equation number 2. So I can write squaring and adding equation 1 and 2. So we can write there, as we are squaring, r square cos square delta plus r square sin square delta. What is the value of cos delta? a1 cos phi 1 plus a2 cos of phi 2 square plus a1 sin phi 1 plus a2 sin phi 2 bracket square. Okay. Now squaring and adding means here we have to apply the formula of a plus b bracket square. Friends, take r square as a common, so cos square delta plus sin square delta. Now a plus b bracket square, a square plus 2ab plus b square. So in that way we can write the expression here for this bracket, a1 square cos square phi 1 plus twice a1 a2 cos phi 1 cos of phi 2 plus a2 square cos square phi 2. So this is the explanation of expansion of a plus b bracket square, a square plus 2ab plus b square for the first bracket, plus for second bracket a1 square sin square phi 1 plus twice a1 a2 sin phi 1 sin phi 2 plus a2 square sin square phi 2. Friends, purposefully I have written these steps each one below the other so that it is very convenient for us to take out the common terms. Now we know that the sin square theta plus cos square theta is equals to 1. So the next step will be here. We can write r square is equals to. Now take out the a1 square as common. So a1 square into the bracket we can write the sin square phi plus cos square phi 1, sin square phi 1 plus cos square phi 1 plus take out the a2 square as a common here from this last step. So again we can write here sin square phi 1 sin square phi 2 plus cos square phi 2, and now take out the twice a1 a2 as a common plus twice a1 a2 into the bracket cos phi 1 cos phi 2 cos phi 1 cos phi 2 plus sin phi 1 sin phi 2. Okay, so the next step will be here r square is equals to sin square theta plus cos square theta 1. So we can write here a1 square. Now twice a1 a2, or we can write here a2 square plus twice a1 a2, and this cos phi 1 into cos phi 2 plus sin phi 1 sin phi 2, that is the formula cos of phi 1 minus phi 2. So if we take the square root, we can get the formula r is equals to under root a1 square plus a2 square plus twice a1 a2 cos phi 1 minus phi 2. So this is the formula for the resultant amplitude for the composition of 2 S.H.M. This is the part 2. Friends, I am going to explain this part 2 once again. So equation for resultant amplitude, squaring and adding equation 1 and 2. We know that the equation 1 is a1 cos phi 1 plus a2 cos phi 2, and equation 2 is a1 sin phi 1 plus a2 sin phi 2. So as we have squared and added, so here r square cos square delta plus r square sin square delta, take r square as a common, cos square delta plus sin square delta. So here a plus b bracket square, a square plus 2ab plus b square. So a1 square cos square phi 1 plus twice a1 into cos phi 1 cos phi 2 plus a2 square cos square phi 2 plus here a1 sin phi 1 plus a2 sin phi 2 bracket square. So same formula a1 square sin square phi 1 plus twice a1 a2 sin phi 1 phi 2 plus a2 square sin square phi 2. Remember, I have written the expansion of the first bracket and below the second bracket so that it is very useful for us to take as a a1 square as a common. So cos square phi 1 plus sin square phi 1 will be here. Take a2 square as a common, sin square phi 2 plus cos square phi 2, and take twice a1 a2 as a common. So cos phi 1 cos phi 2 plus sin phi 1 plus sin phi 2. We know that the sin square theta plus cos square theta is equal to 1. So we can write the r square is equal to a1 square plus a2 square twice a1 a2, and this is the expression of the cos phi 1 minus phi 2. So r is equal to under root a1 square plus a2 square plus twice a1 a2 cos phi 1 minus phi 2. This is the second case. This is the equation for the resultant amplitude. Now the part third, which we are going to see, that is the equation for phase angle. Equation for phase angle delta. Now here we have to divide the equation 1 and 2. Already we have considered that equations. So divide the equation 2 by 1. So equation 2 has the formula r sin delta is equals to, what is the value of r sin delta? So we have considered that formula, that the sin phi 1 plus sin phi 2 and divided by r cos delta cos of phi 1 plus cos of phi 2, sin phi 1 sin phi 2 and cos phi 1 plus cos phi 2. So here a1 you can write here a1, or you can write this separately also, or you can write the plus a1, you can multiply the a1 sin phi 1 plus a1 sin phi 1 plus a2 sin phi 2 upon a1 cos phi 1 plus, you can write here a2 cos phi 2. Okay, now sin upon cos is nothing but the tan. So tan delta is equals to a1 sin phi 1 plus a2 sin phi 2 upon a1 cos phi 1 plus a2 cos phi 2. And if we take the inverse here, then we can get the value of delta. So finally we can write the equation as a delta is equals to tan inverse a1 sin phi 1 a1 sin phi 1 plus a2 sin phi 2 upon a1 cos phi 1 plus a2 cos phi 2. So friends, this is the total mathematical part. Here sin and the cos we have divided. So sin and cos, the ratio is tan theta, and delta is equals to tan inverse the whole bracket we have taken. So friends, today we have seen the one of the important point from this topic, that is the composition of two S.H.M having the same plane and along the same path by the analytical method. Here we have divided the equation into three parts. In the first part, we have find out the composition of the two S.H.M. In second part, we have find out the resultant amplitude, and in third part, we have find out the equation for phase angle. So I hope you have understood this formula and try to make the notes properly. Thank you. Have a nice day.